Hi friends, welcome to my channel. Let's have a look at problem 646, maximum length of pair chain. In this video, we're going to share a treatment based on transforming the current problem or regarding the current problem as the interval merge type problem. So we're going to share three formats of code gradually from the outlier to the core of the problem. First, we'll read through the problem statement, and then we do the analysis, and finally we share the different formats of coding. So first, the problem statement. We are given an array of n pairs, where pairs I equals left I and right I, with the left I strictly less than right I. So a pair CD follows a pair AB if B is less than C. A chain of pairs can be formed in this fashion. So we are required to return the length of a or the longest chain which can be formed. So we do not need to use up all the given intervals. We can select pairs in any order. So this is the main problem statement. So here the return is the length of a or the longest chain, so not the actual longest chain. So actually we can write our code to return a longest chain. So this is one point. Another point is the definition of following, right? So if we regard P1 and P2 as two closed intervals, and then P2 is strictly to the right of P1. So this actually is the follow-up relationship. So here are two examples. Let's first look at example 2. So in example 2, so the output is 3. So the chain can be 1, 2, then followed by 4, 5, and then followed by 7, 8, right? So actually, if we do a sorting according to the start of the closed interval, so we will have 1, 2, 4, 5, and 7, 8. But the intervals in the pairs is not necessarily in sorted order originally. So this is about example 2. So in example 1, so the output is 2. So if we choose 1, 2, and then we can choose 4, 3. So this 2 actually is the longest chain for this problem. So the return is 2. So if we choose 2, 3, actually we cannot choose 3, 4 because this two intervals touches at 3. So with that said, let's also look at the constraints. So first, n is the pair is the length of the pairs list, and it's bounded above by positive 1000, and also left and right is bounded in absolute value by 1000. So with that said, we are ready to do the analysis. So here again, this problem actually is another example of the interval merge type problems. So if it's actually good to see the videos for Leetocde problems, say 56 and 57, actually more for the problem prototypes. So here we would regard each pair, left and right, as a closed interval, and then we could interpret this task as removing minimal number of intervals to make the intervals in the list non-overlapping. What we need to return is the number of intervals left. We could do the removal following the general line of solving this kind of problems by sorting plus filtering or checking according to specific use cases. In this video, as we mentioned at the very beginning, we're going to share three formats of codes gradually from the outlier to the core of the problem. So next, to demonstrate the key point, let's cook up an example. So here, let's consider this pairs list. So it consists of intervals 1, 3, 2, 4, and 4, 5, where the pairs are already in sorted order, right? So we first look at the pair or interval 1, 3. So we make a count 1 because this counts this itself. And then we can examine the closed interval 2, 4. As these two intervals have overlap, we couldn't include both. So we pick 1, 3. So this way we could add 4, 5. So if we had chosen 2, 4, right, we couldn't add or include 4, 5 anymore because these two intervals touch at the point 4. So the grid selection above is the key to our coding here. So with the analysis above went over, so let's look at the coding. So as we mentioned, so we're going to share 3 formats of coding. Let's first do one, right? So here, let me track the length of this nums list. That is m. This is just for convenience. So the next essential operation is to do the sort. So here I'm going to do the sort in place. So here I'm going to use the key. So actually just you need to sort and then leave it as it is. But here to specify the idea, so I'm going to use a lambda function. So here is x0 and x1. So the second sorting key is not that essential. As I mentioned, you can just ignore this key. So after we do the sort, then next we want to build actually a longest chain. So for this, I'm going to initialize a stack and then include the first elements after sort, right? And then we are going to initialize the answer variable to be 1. The final state of this answer is what we need to return. So with this preparations, so we're ready to do the for loop. So for I in range. So now we are going to start from index 1 and ending at n-1. And then we're going to get the start or end, right, of the current interval we are looking at. And then what we're going to do is to check if the current interval follows the top element in the stack. If so, we can increment the count and add the current interval. If they have overlaps, so we need to determine which one we want to choose. So first, let's consider the case. First, is strictly larger than stack, the top element, the end, right? If this is the case, it means the current interval and the top elements in the stack have no overlap. So in other words, using the terminology of this problem, the current interval follows the top element in the stack. So this case, we're going to add this to the chain, right? Add nums I, and then increment this answer variable by 1. So this is one case. Another case is that the two intervals have overlap. So in this case, if the end of the current interval is no larger than the stack element. So in other words, this current interval is smaller, right? So in this case, so we would choose the current interval. So we're going to do pop, and then we're going to stack append nums I. So due to the pop and the append operations, so the overall effect is that the length of the stack does not increase or decrease, right? The reason we choose the current interval because it's end at a smaller number, so it has more chance to be followed by other intervals, right? So with that done, so we're ready to return the answer. So this actually forms a solution format, and here the stack will corresponding to the longest chain we found, right? So now let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic cases. So here actually we can print out this stack. So for this problem, the stack is not necessary, as you can interpret. So now let's look at this one. So this is going to give us 1, 2, 3, 4. So now let's look at the second example. There, I will give this one 1, 2, 3, 4, 5, and 7, 8. So with that said, so we finished the first version of solutions. Let me copy this function signature and then make some improvement. So here I'm going to call this one version v1. Actually, we can copy this part and do modifications in the here. So first, this should be kept, and the thought is important. And then I'm going to delete this stack, right? Because this is not that's important. We just need to track the intervals. So for this purpose, I'm going to introduce as start and end, that is nums 0. This is the current state. And then the answer means that we count the current interval. And then we do the iteration, right? So first and second. And then we're going to consider if the first is larger than the previous interval end. If so, we just need to reset the current state corresponding to do the append, right? That is S and E equals first and second. In other words, the current interval. So we add the answer by 1. Otherwise, so if this second interval is less than or equal to E, so right, so we are going to do this. So we are going to pick the current interval, so that is first and second. So then we just need to return this answer variable. So this is the version v2, right? So we actually do not need the specific stack or track the longest chain. So let's do a check. Yeah, it passes all the test cases. So with the second version done, let me copy this part and then make further modifications. So here, let me copy this part and then change this function signature to be v2. So here, as you can see, the main point is that we track the end of the previous interval. So for that purpose, so we are going to do the sort. That the sorting is very important, right? So as we did the sort, so we just need to do this. We track the end of the previous interval, and then we initialize the answer. And then what we are going to do is that we first get the first and the end. Then if the first is larger than the end, right? So then we're going to set the end to be the current end, right? And then otherwise, so we just need to pick the smaller one, right? So we're going to set E equals E and the second. And then we return the answer. So this is the third solution format. So let's do a check. Yeah, it passes all the test cases. So here, through these 3 versions, we demonstrated a gradual process from the original thought to a simplified version of code which touches the core of the problem, the core logic. So with that said, I guess that's about it for this specific problem. So here our treatment is that so we actually regard this problem as a general interval merge type problem, similar to that for problem 56 and 57. In other words, the prototype of the problems. And then we solve this problem using the sorting and the filter or checking procedure. So with that said, I guess that's about it for this video. So we have a playlist on this kind of problem. You're welcome to check out and actually add more about this kind of problems. Or you're also welcome to check out other videos in our channel. So for discussions, for new ideas, I hope that you can spot something new. With that said, I guess that's it. Thank you.